Let's take a look at a demonstration. We're in SQL Developer, and we'll use the Applications table to demonstrate what we've just seen. Right now, the only index I have on the Applications table is the primary key. So let's go ahead and create our first index. This index will have the zip code column in the first position as the leading edge of the index, then last name, and then first name. So let's go ahead and create this. And there we go. And now we'll have this query here, which has conditions in the where clause for the last name and the first name, which are the second and third columns in this index. So we'll run the query using the auto trace so we can see the plan Oracle used to execute the query and some stats about the query execution. Okay, we see that Oracle did not use our index here. It did a table access full, and this is because we don't have that leading edge of the index in our where clause. We'll take note of the cost of this operation, which is 478, and the number of logical reads, which is over 1700. And we see from the last output rows column, the query did produce only one row, so we worked pretty hard to get that one row. Let's go ahead and add an additional where clause to this query for the zip code and see that we do use the index then. We'll execute this query again, and we see indeed now we are using our index. The issue here is that we might not know the zip code value to use in this query. So what we really have is a mismatch between the index that we have and the data that we're likely to know. So let's try out a different index that has the data that we're most likely to know at the beginning of the index. So we're going to go ahead and drop that index that we just created. And now we'll create this index, of which the column order is last name, first name, and zip code, as you see. Okay, so there we go. Now let's go ahead and get our query back. We'll clean things up here a little bit in our window. And we're going to run this query. And we see that this query is indeed using the index that is created. And what this is driven by is that we have a match between the first two columns in our index and those columns being in the where clause. Now if we go into our query and we get rid of the last name column here, so we don't have that first column again, we see we're back to using a full table scan. So let's do one more example. And what we're going to do here is we're going to get rid of the second column that is in the index. And we're going to add in the zip code column. So that now we have the first and third columns in our index. And now let's see what we get when we run this. So we see that we are still able to use the index. Our cost is a little bit higher. And what this is driven by is that Oracle's first having to read all the entries in the index that have the last name of Harris. And then after it's read these entries, it's applying the filter predicate of zip code to those entries, but that's after they're read from the index. So to wrap up column order, what we want to pay attention to is that when we're working with indexes in your SQL statements, we need to pay attention to the order of the columns in the index and what columns are included in our where clauses. We always want to have that first column of the index in our where clause. And ideally, we want to have as many columns consecutively from the beginning of the index as possible in our where clause to make sure that Oracle can use our indexes.